The Purdue University College of Agriculture has a long history of impact in research, education, and cooperative extension to improve agriculture and the role of agriculture in our society. One of the ways that we continue to do that is in this realm of digital agriculture. It's the fusing of our physical and social worlds to make improved data-driven decisions and actions. So you'll see a website up there in the corner. We encourage you to visit that, purdue.ag/digag. I'm Dennis Buckmaster, a professor of agricultural and biological engineering, and I also serve our dean and our associate deans as a Dean's Fellow for Digital Agriculture to coordinate activities in the college, at the university, and through to external stakeholders regarding data-driven, technology-intensive agriculture. One of the projects that we have is the Wabash Heartland Innovation Network. The WHIN project is not exclusively a Purdue project. It is a partnership with WHIN, the organization, the community foundations in a 10-county region of west central Indiana, of course Purdue, as well as Ivy Tech Community College, and many partner organizations, farms, manufacturing firms, etc. The focus of the WHIN project is to increase the role of advanced technology in agriculture and manufacturing. In this series of brief presentations, you're going to learn of how the WHIN funds are being used to advance the technology in agriculture. So whether this particular video covers the capturing, the clustering, the collecting, or the computing, you'll have to wait to see. But in each of these cases, we are moving forward the technology in agriculture through digital means.
Good day to you all. This is a WHIN status update on the Internet connectivity and Internet of Things project for a livestock facility. The principal investigator for this is Dr. Bob Stwalley of Agricultural and Biological Engineering. Co-PIs are Dr. Dennis Buckmaster, also of Ag and Biological Engineering, Dr. James Krogmeier of Electrical and Computer Engineering, and Dr. Allan Schinckel of Animal Sciences. Some background on this is that we are looking to add a precision livestock instrumentation suite to a farrowing barn at ANSEC, the Purdue Ag Center for Livestock. With that, you have decisions to make about whether or not you're talking about a real-time setup or a batch setup, whether you're looking at open range or confinement animal systems, and whether you're interested in operational or physiological data on the animals. The objectives for this specific program is to work with the farrowing barn for swine. We're talking about an integration with the Purdue cooling pad, and we're talking about both operational and physiological sensors, and we will have real-time connection using wireless connectivity to a server within the building hooked to the internet. In terms of technology development, we'll be coupling existing sensors which do both humidity and temperature. We're interested in audio and video data. We'll be taking information from the cooling pad suite, skin temperature of the animal, and thermal photography. In terms of what we have under development, we're interested in a real-time feed scale for what the animal is eating, as well as real-time water use, potentially using a turbine flow meter. Other developments that we have going on, we're looking at a real-time longitudinal scale for the animal with load cells. We actually believe we have the potential to tell with a sophisticated enough scale whether or not the animal is laying down or standing. And we're also talking about a longitudinal vaginal temperature probe for the sows. Current technology only allows about 2 to 3 days worth of data, and we're looking at developing developing something that will work for a much longer period of time. The experimental program that we have with WHIN is actually directly supporting a graduate student, Tyler Field. The primary objective for this program is to create centralized data connectivity, and we hope to use this connectivity in the farrowing barns with other technology we have, such as the indirect calorimeters, the Purdue hog cooling pads, different operational metric calculations that we'll be performing in real time, along with physiological health measurements. The experimental program itself should be a roadmap for the inclusion of precision livestock instrumentation inside at least confinement facilities. One of the real difficulties associated with confinement facilities is the operating conditions inside these buildings are incredibly harsh and very limiting to electronics. We've got some experience overcoming this, and we hope to continue pushing forward on that frontier, and we're intending to support ongoing heat production, heat stress, and genetics research in swine with our experimental program. In terms of anticipated results from this, we absolutely want to demonstrate an Internet of Things coupling inside of a farrowing barn. We also want to demonstrate an additional, the robustness of at least our ability to seal these sensors inside that, and again, looking to add to the heat production database and operational database for the calorimeters and the hog cooling pad, along with work on the swine genetics database under production at Purdue at the moment. If you have any questions, please feel free to contact the principal investigator. I can be reached at rms3@purdue.edu. Thank you this afternoon for your time.
Bob, thank you very much for that overview of what you're doing there with some very good collaborators. I guess my first question would be, you mentioned somewhere along the way some operational metrics and calculations. What are you thinking of there in terms of the operational metrics?
They're interested in the animals' feed consumption, and the closer to real time we can get with that feed consumption, the more they'll be able to use that information. I mean, certainly at the moment you can come reasonably close over a 24-hour period if you're feeding them a certain amount, and at the end of the day they've consumed it all. But we would really like to know where during the day they're consuming that food and how much of it are they taking, at any one eating period. So feed consumption is one of those things. One of the things that our animal science people are very excited about knowing is actually the animal's water consumption. There's no real extensive published data on that, so we're going to work on basically getting a smaller turbine flow meter associated with their waterers. We will also have videos, so if it happens to be an animal that likes to play with that water, we'll be able to make an analytical adjustment to that number afterwards, but at least we'll have numbers on what individual water consumption is going into a particular crate. And then obviously we're also interested in knowing about the animal's weight over time. So we are in the process of actually putting a set of load cells underneath some of the cooling pads so that, again, it won't be accurate from just moment to moment, but spread over the course of several minutes or even several hours, we should be able to get an animal's weight as well out of that. So,
do you have any commercial sensors in play, or are most all of these prototypes or developments out of your lab or collaborators' labs?
I very strongly encourage my team not to reinvent the we will be looking again as much as possible to use existing sensors. Now, as we move to more physiological data, there we're going to have to actually, kind of start from scratch and build from a component-wise assembly to get something. You'll notice that in the slides, one of the things that we actually have OTC looking at, a proprietary disclosure on is a long-term vaginal temperature implant for the sows. And whereas we'll purchase certain electronic components, the actual assembly of that will be that will be on a Purdue workbench.
Okay. Yep. New novel devices. Great. You mentioned in your presentation, and I fully get it because I've also been in these environments, just the nasty environment in some livestock facilities for electronics and their connectors, etc. Will your sensors be a mix of wired and wireless? Will you be using Bluetooth Low Energy, LoRa, Wi-Fi? How will the data flow in your instance?
Well, I think you're absolutely right. I think we will actually probably use a combination of both wired and wireless transmission paths. We need a small microprocessor in place to do certain control functions on some of the equipment that we have, and that microprocessor, of course, has a lot of extra computational capability associated with it. So our thinking, at least at the moment, will be to kind of use that microprocessor as a centralized collection point per crate, and then have it wirelessly broadcast to a local server within the building or within servicing larger rooms.
Okay, good. So it's all okay. My last question might require speculation. I don't know, but I was thinking about, as you're talking about the feed intake and the water intake and the other measurements, are there any data that you think you'll be generating that would be useful for what I call within the day decisions that the farmer or the site manager might be making? So rather than the strategic, season-long, cycle-long decisions, but would any of this data help improve the tactical, the day-by-day, minute-by-minute, within the hour, those sorts of things?
Absolutely, we certainly think so. Particularly on feed consumption, if we have an animal that is absolutely not eating, clearly there's something not right there. It would be the same thing if an animal, attempts to gorge herself all at once, on a day's feed. That's a bit abnormal as well. So feed tip-off would certainly be that. The scale that we told you that we're attempting to put together with the cooling pad, we actually believe that with multiple load cells, we should be able to get a coordinated signal, which would allow us to know whether the animal is laying down or standing up. And certainly our animal welfare people have certain guidelines, and so we should be able to, eventually get a program that would look at that data and let us know, if an animal is just never getting up, that of course is no good, or if an animal is spending an excessive amount of time on all four legs, we know that also is an indication that she's not feeling well.
Well, again, thanks for the report. Thanks for some good answers to these questions. Really excited about the prospects for digital livestock.
Well, we are too, Dennis. We really believe that this is my team thinks this is a pretty open frontier, and we're very excited about the possibilities in front of us here.